Hi guys, welcome back to the podcast. Today we have a guest, Richard Warry, who I think we first met on LinkedIn.
Yeah, in a thread on LinkedIn,
AKA Heat Pump Man.
Yeah.
Right. I wanted to find out, he was saying quite a few things that were very interesting on LinkedIn, way more experience in heat pumps than me. My bag is hydronics. And I thought we need to get this guy in and speak to him. So we've saved our conversation for camera, and here he is. Thank you very much for coming in.
Thanks. Yeah.
So just want to tell us a bit about your background, like who is Heat Pump Man, why is he Heat Pump Man, and what does Heat Pump Man do?
Okay, Heat Pump Man exists because all the other Marvel, characters were taken, Spider-Man, Batman, all the best ones. So second best, Heat Pump Man.
I was called Ladder Man on site because I didn't need a ladder for anything because I'm 6'5".
Okay.
So Ladder Man's taken too.
Yeah. Well, I suppose actually one of my customers told me that I was Heat Pump Man.
Right, okay.
And I thought, we're selling heat pumps. It's a good place to start.
Yeah. So you're selling heat pumps?
Yeah. So we distribute them to mechanical contractors and help consultants design systems.
More commercial or a range?
Yeah, commercial systems generally. Small commercial, sort of 40 kilowatts up to 2 megawatt systems.
And how did you get into it? What was your starting point?
I've actually worked in mechanical services now for 24 years. So,
how old are you? Can I ask?
42.
Okay.
Yeah. So not ancient, but yeah, since I was 18.
Yeah.
So I started off with all of those, dirty fossil fuels.
Yeah.
So I was working for a company who did industrial warehouse heating, sold boilers, that sort of side of things. And I've been an applications engineer for my whole career. So, yeah, I suppose I first started working with heat pumps 16 years ago.
Mm-hmm.
I worked for Mitsubishi Electric. I went to Mitsubishi Electric purely.
They're also based in this building.
Yeah, so I understand.
Yeah.
So it's probably 4 years ago that I left that business, but gained a lot of experience. I suppose first commercial heat pump system which I was involved with was probably 15 years ago, which was about a 150 kilowatt system for a private school who wanted to decarbonise.
Okay, and would that usually be ground source or air source? Or?
That was an air source system. I mean, we didn't specifically have a commercial heat pump to sell at Mitsubishi Electric. At the time, we were doing some heat recovery from VRF systems. Yeah. So the byproduct of cooling, obviously heat.
Yeah.
And so we'd have refrigerant to water heat exchangers, which would recover that heat for domestics or whatever other heating in the building.
So 150 kilowatt system, is that made up of lots of air?
That particular system, we had 2 outdoor units, which were about 75 kilowatts each, and then 6 25 kilowatt refrigerant to water heat exchangers in the building.
Okay.
So I took a product which was probably designed to be used slightly differently and reapplied it. Okay. Because at that point, there was a requirement for commercial heat pumps, but there weren't really the products available.
Yeah. And so what it was Mitsubishi, your last company you were at before you set up?
Yeah.
ICG pumps?
Yeah.
And then how long did you start up ICG?
It's been about a year and a half now.
And was that like a nerve-wracking thing to go and start up something like that, or?
I suppose the whole concept of the business is to help and support the industry. Equipment which theoretically could do a really good job at carbon saving and running cost saving, I don't think is. Mm-hmm. And that's down to a number of things which are an effect of how the commercial market works, and which is very, very different to the domestic side of things. Generally, a system will be designed by a consultant that will then go out to tender to loads and loads of building contractors. A load of M&E contractors will price that. When one of those eventually wins it, they then use a load of subbies. So we've got one guy who's installing the water pipe work. We've got one guy who's doing the BMS. We've got an electrician. We've got someone else who commissions the water side of things. In that, there is a lot of opportunity for things to not go Well,
I mean, that's the story all over, really, isn't it? My background's actually commercial. I started 18 on commercial building sites, piping up fan coil units, moving into sort of becoming more self-employed and doing a mixture of commercial and domestic. You knew when you were on a consultant's job because it was just double whatever you needed and the same copy paste design every time. When it was someone who was a bit more involved, it was a completely designed properly to fit the application, right? So
I'm not going to criticize these guys too much because these are my clients. But I think possibly the fact that stuff is oversized, the fact that it's not fully designed when it gets to site is more an effect of the construction industry and the way it works, rather than them not being able to do a good job.
Yes.
Design and build exists in the UK, which most commercial contracts are let on. That means that there's only been a small amount of design work done before a M&E contractor picks it up. They have to price it as if they're doing the job with pretty much with a blindfold on. So they then win that job, and then they think, oh dear, what have we missed?
So I heard that system consultants, commercial system consultants, are typically, they charge by a percentage of the total cost of the install. Is that correct? So they're therefore incentivized to put in more stuff.
I think that might have happened in the past when projects were fully designed, where they designed absolutely every single nut and bolt, every piece of equipment. And actually, I think things were better when that was the case.
Right. Okay.
There is so much ambiguity in the designs nowadays that people are picking it up, and straight away they're facing a situation where there's not enough money in the job to do the job properly because there wasn't enough detail. Things have been missed out. The nature that the M&E contractor gets it on means that it's their responsibility to get it right. And so then cost saving things happen, either VEing equipment, so reducing, effectively cheapening it, which they call it value engineering, but it doesn't often bring much value. But it's that fragmented situation where there's loads of people installing that system. In the domestic market with your sort of stuff, generally there's one or two guys. There's certainly one person who's overseeing it, who cares whether that system actually delivers out the far end. With these systems, it's like, I've done my bit, I've done my bit, I've done my bit. It's either not working or it's not efficient. But
absolutely. It's the same. It confuses me when it's house bashing. So you have an electrician go in and do the controls for a heat pump, and then someone else doing the plumbing. That's not understanding what you're putting in. That doesn't work. So actually you do get the same in domestic, but more so in the new build sector than retrofit, where it would be overseen by someone. The whole end-to-end process, you're totally right, needs to be overseen and understood by one person who knows why they've used radiators instead of underfloor or whatever, and then he adjusts the controls, to suit the application, basically. So I think that's like a common thread, but probably more sort of pronounced in your kind of area.
Well, what we're all about is actually working with a consultant in the first instance, making sure that they select the right equipment, which is going to be the most effective, the most efficient, helping them to not miss things which cause issues, and then following that job in through to the M&E contractors when they're pricing it and saying, do you know what's involved here? Have you thought about this? When one of them actually secure it, we will then, if they decide to buy our equipment, we'll follow that equipment to site. We will find out who's commissioning the water, who's doing the BMS, who's being the electrician, and actually just give them all a little YouTube video, a little video that we've recorded saying, for the electrician, put that wire there, that wire there.
Right.
To the guy who's piping the system up, right, okay, there needs to be a pocket here, to put your thermocouple in or whatever else, and just trying to make
joining up
easier for people.
Great, amazing.
But not only that, what we've discovered is that the M&E contractors, the spec might say that the system should be weather compensated, which is a crime if a system isn't weather compensated. the amount which are commissioned, and the M&E contractor says to us, no, whack the temperature right up.
Yeah.
And
So they don't get the calls back. Yeah.
Yeah, and so what we're now doing is following those jobs, offering service and maintenance contracts, but service and maintenance contracts which don't just look after the heat pump. We're saying, can we take responsibility for that whole system, from the controls, the hot water, and really, to be honest, taking that system, and then we're putting enough money in it that we can then change the control set, the BMS, so that we can get BMS engineers there and actually get it working as we'd like it to.
It's just a scaled up version of what's going on in domestic, in my opinion. Like most of the heat pumps going on in domestic are put the flow temperatures right up because we don't want the calls back. And this is before the customers realised how much they're going to pay to run it.
Yeah.
So, and then by the time they do realise and they kind of figure things out, people are long gone. So, it's a common thread. Where do you see, obviously heat pumps are the thing now.
Yeah.
What's the next thing that's maybe coming out? CO2, that was the first CO2 heat pumps. That's the first discussion we had.
You said they're rubbish.
Well, yeah, that was my understanding is they go up to high temperatures, but their scops are rubbish.
Yeah.
Is there any other?
That is true for a poorly applied, poorly designed, poorly installed system.
As with all.
Absolutely. If you've got the wrong product doing the wrong job.
It's
not going to be efficient.
So what's the score with CO2 then? CO2 heat pumps, are they?
CO2 heat pumps are super efficient.
Yeah.
If there's a low return temperature back to the heat pump.
Oh, so it needs a wide delta T?
It's not all about the delta T. It's actually just about the return temperature back to it, and that's relating to the thermodynamics, which I suppose I can explain.
Yeah,
I've come up with a way of explaining that doesn't just baffle everyone. I think anyway. So you can give it a go. You can tell me after. So any other heat pump, we're always searching for the lowest flow temperature possible. So weather compensation, looking at the internal, external temperature, just trying to get that down. CO2, whether you're heating the water to 50, 60, 70, 80 degrees, there's a negligible difference in efficiency getting there. It's all about actually getting that return temperature super low. And ideally, 30 degrees or less.
Okay.
40 degrees is probably about as higher return temperature as what we can deal with. Why? This took me a little while to understand. But effectively, if we understand two really simple bits of science, one being that latent heating and cooling uses the most energy.
Yeah.
So taking moisture out of the air, it doesn't affect the thermostat, does it?
Yeah, so it's the phase change, basically, the absorption and releasing of energy when the refrigerant changes phase from liquid to vapor or vice versa.
Yeah.
Yep.
Yeah. So, or even, even just if you just think about a block of ice, turning it from a solid to a liquid uses lots of energy.
Yes.
So if we remember that's one thing. And the other thing to remember is that all matter can be a solid, a liquid, a gas.
Yeah.
Or we keep on heating it and pressurizing it, a plasma.
Oh, okay, yeah.
Apparently 90% of the universe is a plasma.
Yeah. Isn't that both solid and gas at the same time or something like that?
It took me ages to get my head around it.
Yeah.
There's a 1980s video online which is made by one of the compressor manufacturers, which actually shows CO2 in a chamber.
Yeah.
So it's kept under pressure, and then the phase change from it.
Yeah.
When it changes from a gas into a plasma, you can't tell. It looks a bit like a solid and a little bit like a liquid.
Oh wow.
But in that state, its temperature and pressure correlation disappears.
Yeah.
I suppose the most important thing of this is that CO2 changes from a gas to a plasma at just 30 degrees.
Okay.
Quite a bit of pressure.
Yeah.
I think it's about 70 bar.
Right.
Yeah. So and they call that the critical point. where it
Yes.
changes from a gas to a plasma. So if you think if you're just sitting just below that critical point,
Yeah.
just a little bit of compressor power,
Yeah.
you can push it up to 40, 50, 60, 70, 80 degrees with only a tiny little bit of energy,
Yeah. Yeah. Yeah.
right? Now, we want to keep it in this plasma state
Yeah. Yeah.
for as long as we can, because if we effectively we drop the pressure, then we've got more compressor power to put back in.
Yeah. Yeah.
That makes sense?
Yeah.
So what we need is a cold return,
Right.
which will suck all of the energy
Yeah.
out of the refrigerant.
Yeah.
And we're sucking all of the energy out, but we're keeping it pressurized. So we have like a high pressure valve
Yeah.
on the system.
Yeah.
So and right to the point where we've taken pretty much all of the energy out of it. The refrigerant temperature is getting close to the temperature of the cold water.
Yeah.
And then we drop the pressure, and then it condenses.
Okay.
And then we pick up heat again, but we're just below that critical point.
Yeah.
Tiny little bit of compressor power. Boom.
Yeah. Yeah. Yeah.
Temperature. So,
Okay.
but we've got to control the return temperature.
Yeah. 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 Is it 30-degree return that we want, and anywhere below, as long as it's
Anywhere below it. So I mean, it's going to be most efficient taking cold feed water and heating that right up to 70, 80
yes.
degrees.
Yes.
But really, if like low sort of 30 degrees down to there is your absolute prime. But if it's a little bit higher, if it's say close to 40,
Yeah.
then it just needs a little bit more compressor power to
Yeah.
get there,
Okay.
doesn't
But
it?
we're trying to prevent that extra power going in. Right.
Absolutely, and there's a tipping point of where the return temperature is so high that we have to drop the pressure a lot, use lots of compressor power, and then it becomes inefficient.
Got you. So it needs a bit more thought and understanding to fine tune, or provided you've got the 30-degree or below return temperature, you're pretty much going to be okay, provided you've got weather compensation, all the other good stuff that you should normally do.
It's very, very useful for heating large volumes of domestic hot water.
Yes.
Yeah, so hotel application, leisure application, where like a hotel, all the showers are used first thing in the morning. All of the showers are used sort of 6, 7 o'clock at night. So not only are you working to its optimum thermodynamics, you've also got a really long time to recharge it.
Yeah.
So you actually have big buffer vessels,
Yes.
smaller heat pump, recharge those cylinders,
Right.
use all the water. That doesn't mean that it's not useful for space heating.
Yeah. Okay.
It means that it's more complicated to apply it in space heating.
Yeah.
And so maybe this person that you've spoken about
Yeah.
has used it in a conventional setup.
Yeah.
He's got a 10-degree delta T in the system, and so he's getting very poor results.
Yeah, it makes sense though. But I get quite excited about this sort of stuff because then, if you know what you're doing, you can get you can make things work better. I kind of like the puzzle of putting stuff together. So, exciting. Sorry, we've got other stuff going on here. So we've just moved up to the 5th floor at Sustainable. This is Sustainable Ventures. This building, Sustainable Ventures is it's actually Europe's largest climate tech hub. So all the companies in this building are they either work in Divine Chocolate work here, so they make sustainably sourced chocolate and ethically sourced, etc. There's who are the toilet manufacturers? Can't remember who make the toilets, but they've got like the aeroplane suction toilet things. They're downstairs. They're not the old ones that you might have seen in there. The Airex. Airex make air bricks that go in Victorian homes, but they shut off if you don't need to air underneath. So if the moisture level isn't like too high there, they'll shut off to stop the air moving through and reduce sort of heat loss. So yeah, we were all downstairs from as of yesterday. We were downstairs. We've just moved up here because this is going to sort of quadruple in capacity in the next week or two. So it's a cool
building.
Yeah.
Like it.
Big Ben over there.
Exactly, yeah.
Yeah.
Yeah, you've hit the big time out of it.
Do you know what? Sorry, I haven't even offered you a tea or a coffee or a water. Would you like a drink or anything?
I was quite hot when I was walking in. I don't need anything warmer. So yeah, I mean, natural refrigerants are one of the biggest things which are happening at the moment. And we are, firstly, CO2, if from our view, is the go-to answer for domestic hot water. You get an SCOP 3.5 to 4.
Yeah.
heating water to 70, 80 degrees.
Yeah. Amazing.
Which commercially
Yeah.
is kind of important.
Yeah,
I've
commercially.
seen your video about Legionella, and
That's domestic video. Commercially, you've got to get that temperature right up.
the
without
LA
doubt.
legislation says you've got to hold it at 60 degrees.
Yeah.
And until that changes, and I was speaking to some consultants this week who think that it will.
Okay.
But until that point,
I mean, I wouldn't want to risk, even especially in like places with vulnerable people. I'd be wanting keeping up at 60. I don't care that there's more losses. Health's more important.
Yeah.
So I think, again, the whole idea is it's about suitable for application, right? Not just one rule for all.
Yeah.
So we reference the L8 regulations in that, and we also reference the fact it states for non-domestic properties. Like that's the point of it. So you said natural refrigerants, and natural refrigerants are gases or refrigerants or liquids that can be found in nature, right? So CO2, LPG. What else is there that's natural? That's basically
LPG, which is propane, isobutane.
Okay.
Ammonia.
Ammonia,
with ammonia, but all of these refrigerants were the original refrigerant.
Yeah, because ammonia goes up to super high temperatures, right?
Yeah, and super low temperatures as well. So
okay. It's got a wide operational range.
Ammonia plant is used in big, refrigeration -20 sort of applications.
So why is natural refrigerant good? Is it just because we don't have to manufacture it and that's cleaner, or also because it's cleaner for the environment?
The truth is, we do actually have to manufacture it,
right?
So because it's purified,
right.
So there is a manufacturing process with that.
Yeah.
But they aren't completely manufactured unnatural refrigerants, which we found lots of problems with.
Yeah.
So when I started off with heat pumps, we were working with CFCs, HCFCs. I mean, R22 was commonly used in air conditioning systems.
Yeah.
They found that had ozone depleting potential. That's when it was all that we've got the hole in the ozone layer.
Yeah.
So the refrigerant companies needed to find a new solution. So that's when we started using HFCs. So R407C, R410A. They then found that they've got global warming potential.
Yeah.
And
so they're two different things. So ozone depletion is different from global warming potential because my understanding is ozone layer is a breakdown of the protective kind of layer in the atmosphere. I don't know if you know about that. And then the global warming potential is more about the consistency of the atmosphere that retains the heat energy on the Earth, right?
Yeah, absolutely. Sort of magnifying the heat to the Earth.
Yeah.
So because of that, that's widely recognised. We started HFC phase down.
Yeah.
So
right,
all of those systems which were R410A, were R32.
Right. So that's a new term I haven't heard. It's HFC phase down, and that's kind of what they're going through at the moment, where they slowly but surely use cleaner refrigerant.
Yeah,
right?
about 8 years ago, they counted up all of the refrigerant which was coming into the country every year.
Yeah.
They calculated a CO2 equivalent of that.
Yeah.
And they said, right, that is the benchmark. This is how much CO2 equivalent refrigerant that we've got in the system. Now, they didn't enforce manufacturers to move to lower GWP refrigerants.
Yeah.
But if you're a market leader, like Mitsubishi or Daikin, it's in your interest.
What's the whole point of heat pumps, right?
well, the two things are a little bit separate. To be honest with you.
Yeah.
But if they just wanted to sell the same amount of equipment again, it needs to be a lower GWP, because every couple of years they're saying, right, 20% less GWP, a CO2 equivalent.
Yes.
So effectively, they were limiting the amount of refrigerant which should come into the market if it was the same GWP stuff. So
got you.
That forced the manufacturers to start moving to refrigerants like R32, like R454B, which is used in a lot of chillers and heat pumps.
Right.
We started seeing HFOs coming into the chiller market, which are synthetic refrigerants, but were low GWP synthetic refrigerants.
Quick point, GWP, global warming potential. carbon dioxide has a global warming potential of 1 because that's the main sort of benchmark. R290, which is what the heat pumps were sort of moving to at the moment, have a GWP of 3, right?
Yeah, well, actually,
We
the
think so.
IPCC have actually done some reporting, and they say that the actual GWP of propane is 0.002. It's a 100-year
So it's 100-year, because this is the difference, right? Because it's to do with the half-life. That's right, isn't it? And
Yeah,
it
well,
breaks
it's
down
20 year
over
and
time.
100-year.
So 20-year is 3. So in 20...
No, it's not even that.
Yeah.
They've literally discovered the global warming potential is low. I'm not exactly like completely au fait with the science, but the same.
Yeah.
The IPCC, the Interdepartmental Party on Climate Change.
Yeah.
They've their report of, I think, last year, they looked at all of these different refrigerants in the atmosphere and are now saying we were wrong on this one. R32 being one of them. They said that the GWP of R32, I think, was 677. They're now saying it's 771.
Okay.
Something along
so
that
that's
lines.
gone up a tiny bit, and R290's gone down below carbon.
Yeah.
Carbon dioxide.
Yeah.
So that's interesting.
But I suppose there's lots going on with refrigerants at the moment. So firstly, we've got a couple of weeks ago, there was a vote in the European Parliament, and there's been, I think 90% of the European MPs voted on this sort of schedule for banning HFC refrigerants.
Right.
And they've done it by what type of equipment that it's in. But for example, I think that it's proposed that any monoblock heat pump with a HFC refrigerant in it should be banned by 2028.
Right. Okay.
And like split air conditioning units, I think, was maybe 2027. But there was another outcall for all of them to be banned by 2026.
Right.
If you look at the refrigeration market, you can't buy, as of January of next year, you're not going to be able to buy a fridge with HFC refrigerant in it with a GWP of greater than 150.
Okay.
So we know that the HFC refrigerants aren't good for the environment. The government know that it's in a lot of equipment. So instead of going, right, you can't use it, and cutting a load of industry just straight out, they started this phase down,
right,
probably 6-7 years ago. But now they're understanding that we're not meeting our climate targets. So the European Union are going, actually, we need to take action now, and actually get rid of these refrigerants. It's not been passed into law yet, but it's looking pretty likely. It could happen really soon. It will happen in the next 4 or 5 years, definitely.
Interesting. So isn't the only issue, though, really, if it leaks, is the other angle that F-gas is tightened up, I don't think they even have F-gas in the rest of Europe, don't they? Don't they just spray it off into the air?
No, I mean the F-gas regulations are set in the European Union.
Oh, are they? Okay.
They may well still do that, but they create laws which say that.
So I hear that we follow them a bit more stringently.
Yeah, I mean, I think that certainly in the air conditioning industry, there's a lot of training and there's definitely the right culture to be recovering the refrigerants. But systems do leak. That can't be said. What happens when this super sustainable company who are getting rid of equipment for us at the end of its life? How do we know they're not doing what's happening with our rubbish? And so a lot of these refrigerants end up in the atmosphere.
Okay. So going back to the effect of that, is there more refrigerants that have lower than 1 GWP?
No.
Or is it so R290 we think might be one?
Really, there's like I said, the butanes, the isobutane, propane, CO2, ammonia, those are really the options. Now, ammonia, we were using these refrigerants in the late 1800s. Okay.
Right. Okay.
So, in the, I think it was like 1880, the first CO2 cooling system was used.
Where do we get ammonia from?
Where do we? I'm not quite sure.
I reckon what produces ammonia? Anyway,
It will be mined, I guess. Yeah. I mean, I've not done a lot of research because that's not our thing. I mean, ammonia we stopped using because it was toxic. No.
Oh, okay.
It was killing people.
Right. Okay.
CO2 we stopped using because it works at such a high pressure.
Yeah.
We couldn't manufacture
The stuff.
components which would withstand that pressure. Things have changed.
We're there now.
Isobutane, propane we stopped using because we were setting fire to ourselves.
Yeah.
Right. Now it doesn't sound like a great thing to be moving to now, but our engineering capabilities and understanding of how to use these refrigerants are much better than they were. Thermodynamically, they're as good as those refrigerants which are first causing ozone depleting potential, then causing global warming potential. The HFOs, which were then introduced, which are chemical refrigerants as well, but a low GWP. We've now found them to have TFA in it, trifluorocetric acid, which is naturally occurring.
Yeah.
But there's a couple of universities which are studying it now and saying actually the use of these HFO refrigerants is meaning that there's more TFA which is getting into our water systems. Effectively, it's getting into our drinking water.
Wow.
Effectively, a lot of these refrigerants are seen as forever chemicals.
Yeah.
So they're literally indestructible.
Yeah.
And it's really surprising, actually. I heard that 3M, who are one of the biggest manufacturers of these forever chemicals, are now talking about stopping manufacturing.
Same 3M that do the sticky back.
Yeah.
Is it? So.
Yeah. Post-it notes.
Yeah.
But they do everything.
Yeah.
They create loads of chemicals, and they, I think, from a corporate social responsibility or not wanting to get sued point of view, they're stopping making these refrigerants. The writing's on the wall. All these we've had refrigerants which we banned first because they had ozone depleting potential. Secondly, we're now having phase out because they've got global warming potential. We've got this new replacement for it, and effectively that's getting into our drinking water, and they believe can cause harm to human health.
Wow!
All the while, we've got these refrigerants which are natural, thermodynamically better than those refrigerants that we've been using, but we haven't used them in big numbers, and so. Adopting something new is a challenge for some people. But we say you've been using them since the 1800s.
Yeah.
They're phased out because this, and this.
Yeah.
And this is how we now make them safe to use.
It's funny, isn't it? Because basically it's to do with being the more human processed it is, the worse it's. Just as processed food's bad for you. Humans again, we're going back to nature. Yeah. Wow, that's really interesting stuff. So if you had advice for anyone moving into either domestic or commercial kind of heat pumps, and say they were from a heating background or the other way around, perhaps from a fridge background, moving into more the heating side, is there any advice or anything like that you give for that process?
I think there's lots of really good engineers out there. And people are just used to doing what they've always done. And given the right advice and the right training, they're all completely capable of it. All of the consultants we deal with are completely capable of designing good heat pump systems.
Right.
All of those heating installers out there, given some training, are probably able to install it.
Will you be able to do some training with us?
On commercial stuff?
Yeah, why not?
No, would love to. The principles really are very, very different with commercial than domestic. That is a little bit down to the equipment which is available. I think that the domestic products have really, really come on in recent years. Yeah, I think there's been a lot of development in those products. What do you fit?
We mainly fit Valent, but we're kind of open and whatever suits the application. So Valent at the moment are R290, they don't fit in some places, so I say us, it's mainly the heat geeks who we help support that are mainly fitting those.
And that's got a variable speed pump. The inverter will turn right down, will it?
Yeah, there's some issues with the variable speed pump. We're not getting it to modulate very much, so that's not very helpful. We're trying to work on that and get that fixed at the moment. One thing I would say Valent are very good at, as are Viessmann, is their heating controls, their weather compensation. Make sure that flow temperature is low as possible.
Right, yeah.
Other manufacturers kind of have like a bit of a rigid weather compensation where you have to have an on-off stat to control the weather compensation. If you've got good weather compensation, you don't need an internal thermostat. It'll just maintain the temperature, provided you've.
It's just ramping up the flow temperature.
Depending on the outside temperature, and that's all it does. That doesn't work quite as well in new builds or high glass, because you can have internal gains and that sort of thing. But so I do really like the Valent, and Viessmann have been in refrigeration for 100 years, haven't they? I think they might have even been in refrigeration before they were in boilers potentially.
Right, okay, yeah.
I know a lot of the commercial kitchen, commercial, so fridges in supermarkets are often Viessmann.
Okay.
Iceland fridges are Viessmann.
Really? Right, okay.
Yeah, not that I go to Iceland much. I don't mind.
So this
Iceland.
is part of the heat pump sales pitch to you.
No, it's just me walking around Iceland. Go, is that Viessmann? That's and get dragged around. It's like when you go on holiday and first thing you do is look under the sink. Well, I do. And see the pipe work and stuff.
One of our engineers, first thing he does when he gets into a hotel is he takes out the filter.
Checks.
And cleans it in the shower.
Because it's quite often left, isn't it, as well?
Oh, yeah. No, and he sends me a picture.
Yes. Thanks, mate. Yeah. How many guys have you got? Many guys working for you then?
To be honest, we've got a few direct employed guys, but we are effectively a commissioning service, and we do service and maintenance. We're not installing the equipment, but I suppose from experience we learned that actually the customer needs some help on site. You've got to be a little bit more understanding. You need to turn up there and just saying that's wrong. That's
really
wrong.
Good.
I'm off. Doesn't help anyone.
That's really, really good and interesting service. So like you guys help see the end to end with the different trades, and then you'll also come in and commission, fine tune, and make sure the dots line up essentially.
Yeah, we'll do that as much as we can. Like I say, the contractor doesn't always want us to do that. Now we're getting an opportunity after the 12 months defect's over to actually go and speak to that end client, explain to them, that we can make that system more efficient, then try and do their service and maintenance, and that to cover their whole heating system, so that it can get the absolute optimum out of it.
Well, so what I'll tell you what,
I was wrong.
This isn't about Heat Geek, it's more about you, but just an idea of what so as you know, we're like a YouTube channel, and we've done training now. We've partnered up with, I've got a new business partner, Adil, whose background is Apple, and he has a lot of experience in techifying, or what's the other word, digitizing. His background is using technology to enhance how people do work. So he's worked for British Airways, NHS, and he'll use Apple products to kind of digitize their process to streamline it. So we've kind of come together, hence been in this building now, and now everything I have is Apple. I've got an iPad, which is I was dragged kicking and screaming to it. But there is a thought process that's slightly different because it's all much more intuitive. So we want to provide stuff to engineers that aren't work for them to use. They're not like they're having to work out a spreadsheet. They're natural and intuitive, and that's his background. And it
makes their job easier.
Yeah.
And there's not an upfront investment of time to really understand it.
Well, it's not even their job, their life. It fits into their life just the way. So it's on their phone rather than having a separate PDA or all of that sort of thinking kind of comes together. And that's why we're up here developing that sort of stuff as part of the new Heat Geek 2.0, which we'll hear more about at some point. But I don't know if there's anything that we'll be able to do for commercial or not. But commercial, difference between commercial heat pump engineer. Is it a heat pump engineer? It's just a refrigeration engineer?
It doesn't really exist. It's not even that. M&E contractors have a load of trades, subbies generally.
Right, and they kind of pull together.
Absolutely. So you have a project manager, but this is, I'll say it's worked for I mean, design and build contracts really only came into place about 15 years ago. Before that, everything was fully designed and things worked. Now there's all this ambiguity. There's a really long tender period, and then just before the orders, they've got to be on site on a £20 million bill. They're giving someone an order. They haven't got time to design it.
Right.
and then you've got a load of trades which come and touch all of this equipment, which is why in the past everyone's just turned up the heat, got all the pumps running constantly, you know, and because it's gas, no one notices. Now, a lot of what we're doing is public sector decarbonisation schemes. So the government are giving grants to, you know, to public sector bodies. So the police, to leisure centres, hospitals, all the rest, to decarbonise.
Yeah.
And the jobs have been tendered in pretty similar way.
Yeah.
Now, you know, electricity is 4 times
Yeah.
you know, more expensive than gas.
Yeah.
Now, if a heat pump is misapplied and you're getting an SCOP of 2 and it's replaced a gas-fired boiler,
they're not happy.
We're going to be what, 3-4 times lower in carbon still, but it's going to cost double to run. Now, if that's on a hospital, there's quite a lot of money involved there, and I don't think that a lot of the people who are driving these things are fully understanding it, because we're picking up projects which have been specified with another manufacturer, and then we look at the carbon calc, and they're saying we're going to get an SCOP of 4 on a conventional heat pump doing 70 degrees with no weather compensation.
We know it's not going to happen. What's a typical SCOP or SCOP of sort of higher end SCOP of a commercial system?
If you get all of the design right, it's set up on weather compensation.
Yep.
We've got all the hydraulics right. We've got a ridiculously sized buffer.
Yep.
And we've got the right delta T's in the system. Then we'll get an SCOP of about 3.5. That's if everything's done right.
Okay.
Yeah. So with a conventional,
really tight margins, isn't it?
it is. And the thing is like we can't really, unless it's a very, very small commercial, we can't have those sort of open circuit systems that you talk about.
Completely different.
Because you've got loads of different
rooms. No, it doesn't work.
Different temperatures.
Yeah, like in our Should We Zone on heat pumps video, we talk about, unless it's a big commercial building, or like commercial does need zoning. There's no other way to deal with that.
We've done a couple of commercial buildings where there's just a couple of heating zones. And we've had, say, a 20 kilowatt heat pump doing one circuit and another one doing, and actually
you divide
treat it like two
and then you've got more modulation there anyway, because there's two heat pumps to play with,
and it controls on the flow temperature control, like you say, with a commercial system, conventional heat pump, SCOP about 3.5. CO2, hot water, 70, 80 degrees, SCOP 3.5 to 4. Yeah.
That's interesting. Yeah. Okay.
A lot of these decarbonisation projects we're doing what we call cascade systems. And that's not the same as what you'd call a cascade in the domestic market, because that's just a load of heat pumps manifolded together. We do that, but we just call that a modular system, because it's not really cascading.
Okay. What's cascading?
I think someone just said that once about 15 years ago. Mitzi or Dave.
Oh, we've always called it cascading.
Well, somebody's what we recognise to be a cascade system is a 2-stage system. So we'll have a heat pump doing low temperature hot water.
Then so it's series, not parallel, basically.
Yeah, absolutely. And so you have, say, conventionally what's been done is you'd have a HFC heat pump with, say, R32 in it. Okay, that's doing 45-40 buffer vessel, and then pumped water to a water-to-water heat pump, like a ground source heat pump, which is receiving that 45-40, and then that can do 78, 73 at the other end of it.
And that's how you get the higher SCOP.
How you get the
hot water?
I mean, you will get a higher temperature, and the SCOP won't be penalised as much.
Oh, right. Okay. Got you.
Right? It's still, you know,
Yeah.
if you're going to 70 degrees with a conventional heat pump, you're not going to get a very good efficiency. By doing with this 2-stage, because you're using differing refrigerants, which have got different evaporating condensing temperatures, you'll get an SCOP out of one of those systems, if it's done properly, about 2.7.
That's interesting.
As opposed, if you ran a 70 degree heat pump with a fixed flow temperature all the time, you're lucky.
Of course,
So we're using those cascade systems in a lot of situations where, like hospitals, where they want to decarbonise, but they just can't afford to have the downtime in the building to change all of the radiators and all of the infrastructure.
Yeah.
They need the whole system's designed to run on 80 degrees. So,
I mean, is there another argument that if they can, it matters less if they can also put PV and batteries and use, time of use tariffs, all that sort of stuff?
Yeah.
I suppose you want the best of each, really.
Yeah. I mean, our advice always is with a space heating system, unless you're going down the CO2 route, which as I said, can be done, but it's quite involved.
Yeah.
Is to change all of that infrastructure and get it working on low temperature. That is what we're recommending to people to do. We've come across jobs where because quite a lot of projects we're involved in, just big air handling units with boilers connected to them, and the consultants looked at it and said, right, I need a high temperature heat pump to do this because the coil is built for that temperature. It's actually quite surprising. You don't actually need that much more space in an air handling unit to put in a big enough coil to work on that low temperature.
Yeah.
So we're always asking the questions to try and get them to get that low flow temperature.
Yeah.
But if they absolutely don't want to, we will give them a proposal for a cascade system, but we'll tell them what the efficiency is, and we'll tell them to say, ask your client how much they're paying for gas. And
explain the variables. Don't just give. This is like a common thing. They don't almost want to let people know.
Yeah,
it's the opposite way around to each approach it. Do you find often when you approach a project, do you suggest also like perhaps insulation or changing your single glazed windows to double glazed? It might be because then we get lower flow temperatures.
Fabric first. Get the building. Get the I think the term we always used to use was be mean, be lean, be green.
Right.
And do it in that process.
Yeah.
But some buildings you quite simply can't. Yeah. Some buildings you can't clad on.
We're not allowed to replace these horrible things. Either.
Oh, I don't do that.
Well, they're all right, but they do. I mean, put your hand up to it, you can feel a massive.
Yeah.
drop.
Oh, you can feel the heat coming through. Yeah. I used to live in a flat in Bristol.
Oh right. Yeah.
Which had windows which were bigger than that. And
are you from Bristol? Or
I'm from South Somerset, but I lived in Bristol for about 14 years, something like that.
Okay.
But I'm from deepest, darkest Somerset.
Right. Okay.
So I'm where I live is right on the Devon, Dorset, Somerset border. So we're about 15-minute drive from Lyme Regis. Which,
okay. Nice.
Yeah. Our message is just completely. All these systems are being used to the whole reason that every bit of legislation is in place, every thing which is driving us to use heat pumps is to reduce CO2 emissions. And we want to involve ourselves in projects so they actually get realised. Because actually, I think 40% of the energy which is used in the UK is down to heating buildings, right? Mm-hmm. Okay, so we've been working in what was quite a pouring industry, and suddenly we can have a considerable and decent impact on something which is quite important.
Yeah.
And we can make those CO2 emissions 4, 5, 6 times lower. And that's why we want to get involved with projects. That's what drives our business. The whole natural refrigerant side of things, effectively, we're kind of solving one problem and creating another one. Okay, because we're using a heat pump is reducing carbon emissions from heating, but we're then putting a load of refrigerant into the market, which is damaging to the environment. And so there are other solutions available.
Yeah,
they can. They're designed in the right way. They will do the same job, if not better. So why aren't we moving to them? And so the systems which we recommend to our customers, we fully truly believe that they are the right solutions.
You're right. There's a lot of virtuous signaling, isn't there? Like, oh yeah, we're putting in a air source heat pump by. Oh well, yeah, okay. Yeah, I wonder what the SCOP is type thing, and they've just got the cheapest quote, and it's actually producing way more carbon than it should do because it's not running optimally. And the shame is actually that it costs more to run, so they're not saving any money on the install. Really, people need to spec properly at the beginning. That's the cheapest install. Is the professionally specified one, right? That's domestic or commercial. How have you found, like, we've been in a boring industry and all of a sudden, like this, it's weird that we're sitting opposite Big Ben, isn't it?
Yeah,
With like
really, yeah.
lights and a
Talking about
camera and
heat
like
pumps,
all this stuff.
Yeah.
I find all of this bizarre. Has it been like strange for you or like, or
Yeah, I mean, I suppose when I first get involved with heat pumps, I learned about the legislation and what was driving it. And so I've seen this. I've been waiting for this.
you've seen it coming?
I've been
Right,
waiting
right,
for this
right.
to happen for 15 years.
Yeah.
You know, and so the opportunity is here right now. We need to start doing it properly. You know, is the truth, because certain, you know, projects out there, its installations are giving the technology a bad name. It's always the heat pump. There's something wrong. It's not. It's the way it's been applied. It's the way that it's been installed. It gives people who are pro hydrogen something to point at and say this doesn't work.
Yes.
We really need to. You know, there's lots of people with lots of lots of knowledge, and all of those people need to start working together. We need to care about what's going into these buildings.
Do you think that fight is being won, or we're still?
Well,
it's like we're starting to make the mark that actually perhaps heat pumps are like, they're not all running at Scotland 2. They are affordable. They do work. They don't break down on time. You know, it's fine to run a building at lower flow temperature. Do you think that message is starting to sink in?
I think that no one knew what a heat pump was 15 years ago.
Yeah.
I think probably 4 years ago.
Probably when I first heard of a heat pump.
Yeah, exactly. You know, you're at a party and you say, well, what do you do? Oh, I'm involved in heat pumps now.
Yeah.
No, but now they've got, my.
It's a bit more interesting for me because my sort of geek thing was hydronics and just heating in general. 'Cause that's my bit, which, I mean, it's even more boring, isn't it? And now I get to say I'm involved in heat pumps and it's the flavour of the day. It's a bit, yeah, exactly.
I'm not sure about that. But
to me.
Yeah. I mean, it's about as sexy as it gets in the heating world. You know, because there is, you know, an effect that will
to look at this seriously. This is going to be the biggest dent in carbon emissions in the UK, full stop, more than anything else. So actually, this is the most important thing. We're leading the most important thing to be done in the UK today. Is literally the most important thing. So sexy might not be the right word, but important. Fuck yeah, really important.
And in the domestic market, I think, you might tell me if I'm wrong, I won't say it's one size fits all, but there is an optimum way to design a system which will realise a good efficiency. And that needs to be, you know, your Heat Geek course, absolutely brilliant from what I've seen of it. The people that I've spoken to who've done that course, you can tell they know what they're talking about. So yeah, I'm an advocate of it. I have people ask me about domestic heat pumps, and I send them straight to your website.
Amazing, thank you.
And to those engineers, because I don't want to recommend someone who's going to do a bad job. Apart from anything, in the commercial market, there is such it's all about saying, why are you doing it? Yeah, because some people will, big businesses or councils will want to decarbonise, and they don't really they want to be aware of the cost. They're not necessarily that guided on the operational cost because they need to decarbonise. But there's a different product which is most suitable for each job.
Yes.
And just a high temperature heat pump. Well, what are you using that hot water for? And really, I think what we're trying to do is just guide people in that right direction. Let them go into it with their eyes open.
I think totally. I think that unifying us is, it's not about heat pump or not heat pump. It's about heat pump probably, but also mainly selecting the engineer who's going to specify a system. It's the system specified, not the tech, that makes the difference, right? I think that's like, a good one to close on, because that's totally the same domestic and commercial. I feel like we could probably do another 2 or 3 of these, to be quite honest. Richard,
enjoyed it.
Really good to meet you. I'll see you again soon, I suppose.
Thanks a lot.
Cheers.
Cheers.
Okay, guys, that's it for this one. Thanks very much for watching. If you're listening on Spotify or alike, this is also available on YouTube. If you're on YouTube, vice versa. Make sure you like and subscribe, because that's how we get out. And if there's anything you found interesting or want to challenge, for example, make sure you comment on the comment section below. And if you want to get hold of Richard, you just need to...
email info@icgheatpumps.co.uk. LinkedIn, Richard Warry, aka the Heat Pump Man. Or you can get to us on our website, www. Do I have to say that bit? I don't think
Not
I did.
anymore.
icgheatpumps.co.uk.
You've got YouTube as well?
No, we haven't. No,
Probably
not yet.
will do soon.
We'll see.
Okay. Well, that's it. Okay, guys. See you soon.